Hello everyone. In the last video we have discussed up to question number 68. Now let us do your question number 71. Here in this question number 71, a ball is thrown vertically downward from a height of 20 meter with initial velocity v naught. It collides with the ground and loses 50% of its energy in collision and rebound to the same height. The initial velocity v naught is. Here, in order to understand this question number 71, we have to draw a diagram. For this question number 71, we have what is the given height. The given height is 20 meter, and from this height any object is thrown vertically downward with a velocity v naught. What will be the velocity when it strikes the ground? According to our simple kinematics, we have this v1 square will be equal to v naught square plus 2gh, where v1 is the velocity with which it will strike the ground. And what will be the kinetic energy? Let us consider the kinetic energy to be kinetic energy initial or kinetic energy during the collision, and according to our given condition, half of its energy is lost. Therefore, the kinetic energy with which it will rebound will be equal to half of its initial value, that is v1. It should be v1. This should be v1. Okay, here v1 square. We do not know the velocity v2. Let us suppose v2 is the velocity with which it is rebound after collision, and we do not know the velocity with which it will produce a rebound height of 20 meter. But according to the given condition, the kinetic energy with which it will strike the ground for the first time will be half of the kinetic energy that will be rebound. So if we consider the kinetic energy after rebound to be kinetic energy F, and this will be equal to half into half mv square, because of the given condition. This is given condition. The kinetic energy with which the ball or the object will rebound will be equal to half of initial kinetic energy with which it will strike the ground, and here this will be equal to half into m into what is the value of v1. The value of v1 will be equal to v naught square plus 2gh, and according to work energy theorem, we know that after the rebound it will be now converted into potential energy at the highest point. So if we apply conservation of energy from this point of rebound to the highest point up to which it will rise, will be equal to, at this highest point it will have potential energy mgh, and what will be the kinetic energy just after the rebound? It will be this much. And after simplification, we have this formula mgh in equal to half into half mv naught square plus 2gh, and 2 into 2 will produce 4. This 4 is taken in this side, m and m get cancelled out, and we will be having 4gh equal to v naught plus 2gh, and if this 2gh is transferred in the left hand side, it will be only 2gh root over. Finally, we will be getting root over 2 into 10 into 20, because acceleration due to gravity is taken as 10. And what is the height after rebound? After rebound, it will attain a height equal to 20. So answer comes out to be 20 meter per second. For this question number 71, I will briefly explain how it is done. Initially, as the body is thrown vertically downward, we have to first find out the velocity with which it will strike the ground, because in the question it is given that the kinetic energy just after collision or just after striking is reduced to half. Therefore, for finding out the kinetic energy before collision, we have to find out the velocity with which it will strike the ground, and its value comes out to be v1 equal to v naught square by 2gh, and according to the given condition, this kinetic energy will be reduced to half. That is, kinetic energy will be half mv1 square. And what will be the kinetic energy for the rebound? It will be represented by kinetic energy F, and this kinetic energy F will be half of kinetic energy initial. According to the given condition, we have this kinetic energy final is equal to half of kinetic energy, that is for initial value. We just put the value and we get our answer to be 20 meter per second. Option number D to be our answer. Now let us discuss your question number 72. On a frictionless surface, a block of mass capital M is moving at a speed of capital V, small v, collide elastically with another. And you should remember this. Elastic collision means whenever there is conservation of kinetic energy, we have this three conservation. Cork means it will be conservation of kinetic energy. And what about COME? This will be conservation of mechanical energy. That means it will be equal to potential energy plus kinetic energy will always remain constant. And what about the another famous? This is COLM. There is conservation of linear momentum, and there will be one more conservation in our circular motion, that will be conservation of angular momentum. So far in this collision topic, we will be discussing conservation of kinetic energy and conservation of mechanical energy, along with conservation of linear momentum, and conservation of angular momentum will be discussed in your rotatory chapter. And from the first statement, it is very clear that there will be conservation of kinetic energy. That means kinetic energy before collision must be equal to kinetic energy after collision. On a frictionless surface, a block of mass capital M moving with a speed small v collide elastically with another block of mass capital M. That means we are considering two objects of equal mass which is initially at rest. One was moving with a speed v and another was kept at rest. After collision, the first block moves at an angle theta to the initial direction and has a speed v by 3. After collision, the direction along with the speed is given for the first one. And what about the second? For the second particle, it is not given. The second block's speed after collision means we have to find out the speed after which speed of the second particle after collision. For this question number 72, the collision must have been oblique collision because of the given statement. Moves at an angle after collision, the first particle moves at an angle theta. Therefore, the second particle must have been moved at some angle theta 1 or theta 2. Let us take it as theta 2. It is not recur, but you have to understand this to be the collision between two objects in oblique direction. In oblique collision, there will be change in the direction of the two particle after collision. You can understand this with the help of an example. If this is carom striker, okay, if this is considered to be carom striker and if this is taken to be carom coin, then after collision, the carom striker goes in this direction and carom coin will goes in this direction, making an angle theta 2. Therefore, they can also ask what will be the angle at which this carom coin will move after collision, but this is not required for our calculation because in this question number 72 we can simply apply your conservation of kinetic energy, and from that we can know the velocity with which this carom coin will be moving with after collision. So we can apply kinetic energy before collision will be equal to kinetic energy after collision, because this is elastic in nature. The collision between these two objects is given to be elastic nature, therefore kinetic energy must be conserved. And let us put the value here. What will be the kinetic energy of the first particle? The kinetic energy of the first particle will be mv square plus, and what about the kinetic energy of the second particle? It will be at rest, so we can put this as 0, because half m into 0 square will produce 0. And what about the kinetic energy of the first particle after collision? It will be half capital M into this will be v by 3 holding square plus, and what will be the kinetic energy of the second particle after collision? Let it be v2, so v2 square. And from here we can cancel out half, and we will be having v square is equal to v square divided by 9 plus this will be again v2 square. We just take out half m, or m by 2 is taken common out, and we eliminate from both sides of the equation. If this is transferred, if v square by 9 is transferred on the left hand side, it will be v square minus v square by 9, and this will be equal to v2 square. It will be 8 v square divided by 9, and in order to find the value of v2 we have to just take the square root, and this will produce v2 equal to 2 root over 2 v divided by 3. So our answer comes out to be your option number C. So remember to apply conservation of kinetic energy, because it is elastic in nature. For elastic collision you have to apply conservation of kinetic energy, and if it is not specified whether the collision is elastic or inelastic, then you have to apply conservation of linear momentum, because this conservation of linear momentum holds true for every collision. Now let us proceed to your next question. Let us do your question number 75. For this question number 75, a mass small m moving horizontally along x-axis with velocity v collide and stick to a mass, and we have already understand such type of collision. If the colliding body, let us suppose this is mass m1 and this is m2, they collide with one another, and after collision if they move together as a combined mass m1 plus m2, then such type of collision will be known as our perfectly inelastic. Remember this. After collision, if the two colliding particles moves together with a common velocity, then that type of collision will be known as perfectly inelastic. Anyway, let us proceed to our question. A mass small m moving horizontally along the x-axis with velocity v collides and stick to a mass 3m moving vertically upward along the y-axis with a velocity 2v. The final velocity of the combination will be very simple. Let me draw the diagram. Before collision, this mass m was moving with a velocity v along which direction? Along the x-axis. Let us take the convention. Let it be positive x-axis, this will be positive y-axis, and along the positive x-axis we will be having positive I cap, and along the y-axis we will be having positive j cap. Here this mass m was initially moving with a speed v along the positive x-axis, and what about the second particle? The second particle was moving with a speed equal to 2v. What was the mass? The mass of the second particle is given as 3m and is moving vertically upward along the y-axis with a velocity equal to 2v. so we can put this as 3m, and this is moving in which direction? In the upward direction with a velocity 2v. And after collision, okay, after collision, what will be the total mass? Total mass will be 3m plus m. According to the question, after collision, these two colliding particles stick together and they move with a velocity we do not know. It will be in this direction. Actually, it will be in this direction. Let us put this to be v final, and we have to find out the magnitude as well as in vector form of this v vector. Can we put like this? And this is for your question number 75. We do know that conservation of linear momentum will hold true for each and every type of collision. Here, this type of collision is known as perfectly inelastic. Can we write the initial momentum to be like this? In vector form, it will be m v I cap vector. Why it is being multiplied with I cap? Because this is moving along the positive x-axis, therefore it must be multiplied with I cap. Plus, what will be the momentum of the second particle before collision? It will be 3m. And what is the velocity? Velocity is 2v, and it is moving in which direction? It moves in the upward direction, therefore we must multiply it with jkf, and this will be mv taken common out, it will be I cap plus this will be 6 jkf. This is the initial momentum. And what about the final momentum? For this final momentum, we do not know the direction, therefore we can simply put it as 4m into this vf. We have to find out this vf, and according to our conservation of linear momentum, we will be having initial momentum is equal to final momentum in terms of our vector equation, and we just simply put the value here. This is m v, this is I cap plus 6 j cap, and this must be equal to 4m into this is vf vector. This and this get cancelled out, and we have this v by 4 I cap plus 6 j cap, and this will be equal to vf vector, velocity of the combined particle after collision. Is it in terms of ratio? Yes, it is expressed in terms of ratio, therefore we can express vf to be vf vector will be v by 4 I cap plus, and this will be 6 by 4 j cap, and after cancellation we will be having this is 3 by 2, and let us choose the correct option. It will be our option number B. Finish. Now let us do question number 79. For this question number 79, a metal ball of the mass 2 kg is moving with a speed 36 km per hour. 36 km per hour has a head-on collision. Head-on collision means it is a collision taken place in a same straight line. Then that type of collision will be known as head-on collision. In your question number 72, we have this oblique collision. If the colliding particle moves at different angle, then that type of collision will be oblique collision. And if the collision takes place along a same straight line, then that type of collision will be known as head-on collision. Let us read the question. A metal ball of mass 2 kg moving with a speed of 36 km per hour has a head-on collision with a stationary ball of mass 3 kg. So we have the initial velocity of 2 kg mass, and what will be the initial velocity of 3 kg mass? It will be at rest, therefore u2 will be equal to 0. After collision, both the balls move as a single object, then the loss in kinetic energy due to collision, that is very simple. We can calculate like this. For this question number 79, what will be the diagram? the diagram must be along a straight line. Let us suppose this is 2 kg mass and it was initially moving with a speed of 36 kilometer per hour. Therefore this will be our u1. And what about the second particle? The second particle is of 3 kg mass and it will be at rest. That is why we have to take u2 equal to 0. And after collision, what is the given condition? The given condition is that both the balls move together as a single mass. That means what will be the total mass? Total mass will be 2 kg plus 3 kg. Altogether we have this 5 kg. So what will be the type of collision here? The type of collision will be perfectly inelastic and they moves together with a common velocity v common. Let us put like this, v common, and let us just find out v common. According to our conservation of linear momentum, we will be having 2 into this is 36 plus, and what about this 3 into 0 must be equal to 5 into v common, and we can obtain our value to be v common is equal to how much? This is 72 divided by 5. And if this 72 is divided by 5, 5 ones are 5, and this will be 2 2 5 4s are 20, 5 4s are 22, 0, that means it will be 14.5. What is the final velocity of the combined object? The final velocity of the combined object is 72 divided by 5, and we are being asked to find out the change in kinetic energy or loss in the kinetic energy. Initially, what will be the which object will possess the kinetic energy? Kinetic energy will be possessed only by the first particle. So kinetic energy initial will be half into m. What is the mass of the first particle? It is 2 into, what about its velocity? It will be 36 into this is 36. And what about the kinetic energy final? Kinetic energy final will be equal to half into, what is the mass? Mass will be 5 kg into what will be the value? It will be 72 divided by 5 into this will be 72 divided by 5, and the change in the kinetic energy will be equal to half. We can take half common out and this will be 2 into 32, 2 into 36 square, 36 into 36 minus this will be 5, this 5 and this 5 get cancelled out, and we are remain with 72 into 72 divided by 5, and after simplification we will get our answer to be, for this question number 79, option number D, our answer will be approximately equal to 60 joule. It will be equal to 60 joule. If you can calculate it later on using a calculator, you will get the same answer. Now let us go through the last question. Question number 81. The coefficient of restitution E for perfectly elastic collision. We do know that coefficient of restitution E is nothing but it is the relative velocity of separation divided by relative velocity of approach. Relative velocity of separation means the relative velocity after collision. Coefficient of restitution is the relative velocity of the separation divided by relative velocity of approach. Let us take this m1 initially moving with a velocity u1 and it collide with particle of mass m2 which was initially moving with a speed u2, and after collision let us take their respective velocities to be v1 and v2. What will be coefficient of restitution? Coefficient of restitution is simple. It is relative velocity of separation divided by relative velocity of approach, or you can put like this is relative velocity after collision. Separation means it will be after collision, and this will be relative velocity before collision. And what will be its expression? The expression is very simple. It will be v2 minus v1 divided by u1 minus u2. You should know this. v2 must be greater than v1, and here u1 must be greater than u2 for this type of collision. For elastic collision, that means there must be conservation of kinetic energy. Here, if u2 is greater than u1, then there will be no possibility of collision. Therefore, we must have the velocity of the first particle greater than the second particle, and after the collision, in order to avoid any further repeated collision, this second particle must move faster than the first particle. That is why we take v2 greater than v1. And remember that for elastic collision there will be only one collision. That means there will not be any repeated collision. Therefore, we take v2 greater than v1. So as the collision takes place along the same straight line, we know that relative velocity along the same straight line is the difference of their speed. Therefore, v2 minus v1 will be relative velocity after collision, and u1 minus u2 will be the relative velocity before collision, and its value will be equal to 1 for elastic collision. This value will be equal to 1 for elastic collision, and this is perfectly elastic. Okay, for perfectly elastic collision, the value of E will be equal to 1. And what about perfectly inelastic? For perfectly inelastic, its value must be equal to 0. Perfectly inelastic, where the two body combines together and move with a common velocity after collision. Under that condition, we will be applying E equal to 0. And if the value of E is less than 1, that type of collision will be simply inelastic. Remember this, perfectly inelastic. If the value of coefficient of restitution is equal to 0, then it will be perfectly inelastic. And if the value of E is less than 1, then it will be simply represent inelastic collision, where there will be loss of kinetic energy. Now let us do one last question for this collision topic. Here, question number 77. Two equal masses m1 and m2. It is given that m1 and m2 are of two equal masses and moving along the same straight line with the velocities plus 3 meter per second. Plus 3 meter per second means it is moving in the positive x direction. And what about this minus 5 meter per second? That will be moving along negative x-axis. Respectively collide elastically. Elastically means it will follow conservation of kinetic energy and conservation of linear momentum. Their velocities after collision will be respectively. This is very simple. I will illustrate here. For question number 77, question number 77, we have this. M1, what is the speed of M1? The speed of M1 is M1 is 3 meter per second. This is 3 meter per second. This moves along the positive x-axis. And what about your M2? M2 moves with a speed minus 5. So it will be moving in this direction. This is minus 5 meter per second. This minus sign simply signifies the opposite nature of direction. And for elastic collision, if the colliding particles are of equal mass, then they will exchange their velocity along with direction. Here m1 was initially moving in the positive x direction, so m1 will be now moving in which direction? It will move in the negative x direction. With what velocity? With a velocity equal to minus 5 meter per second. And the second particle will be moving in which direction? It will move in the positive x direction with a speed equal to 3 meter per second. This is the conclusion, and how this is obtained will be discussed with the help of this formula. We have m1 moving with velocity u1 plus, and what about m2? M2 was initially moving with speed u2, and after collision this m1 moves with a velocity v1 and m2 moves with a velocity v2. And what was the formula for velocity of the first particle after collision? For elastic collision, we have this formula: v1 is equal to, very simple, if this is v1 then it must be begin with u1 plus, and what about the second will be u2. And this is the way to remember your formula. For v1 it must begin with u1, and here we must have divided by in the denominator of this two term as m1 plus m2. There will be total mass. This will be m1 plus m2. And what about the numerator? You have to just remember how to write the numerator. We just have to find out the velocity for the first particle. That is why we must begin with the first particle minus the second particle, mass of the second particle, plus for second term it must be multiplied with 2, and it will be again multiplied with the remaining mass, that is m2. This is the way to remember our formula for velocity of the first particle after collision. And what will be the velocity after collision for the second mass? It will be just like this. This will be u2 plus divided by, and this will be u1, and it will be m1 plus m2, m1 plus m2. And for this second particle, it must begin with the second mass m2 minus m1 into u2. And what about this u1? Since this is accompanied with u1, this term must be m1, twice m1. Remaining mass will be twice m1. And let us consider the concept. If we consider m1 and m2 equal, if m1 is equal to m2, if m1 is equal to m2, what are the velocity here? Velocity v1 will be equal to how much? v1 will be, this term will be equal to 0, because m1 minus m1 will be equal to 0, so first term will be 0. And what about the remaining? It will be twice m2 divided by, here this m1 will be equal to m2, therefore we can just put it as m2 into, this is u2. This get cancel out, and we get v1 equal to u2. And what about the second? For the second particle, it will be, this term will be 0, and it will be twice m1 divided by twice m1 into, this is u1, therefore v2 will be equal to u1. That means their speed get exchanged, their velocity get exchanged. Here what is the value of u1? v1, value of v1 is equal to u2. And what about the velocity of v2? It is equal to u1. Simply we can say that for two equal mass, and for the collision of two equal mass, and if the collision is elastic in nature, then they will simply exchange their velocity. If u1 is moving with a speed equal to 3 meter per second and u2 was moving with a speed 5 meter per second, then what will be the velocity of the first particle after collision? The velocity of the first particle after collision will be 5 meter per second. And what about the second particle? Second particle will be moving with a speed equal to 3 meter per second. Simply they will exchange their speed. This is in terms of magnitude. And what about in terms of direction? In terms of direction, we will be using the terminology velocity. Velocity comes along with magnitude as well as direction. To be precise, speed with direction. Here m1 was initially moving with positive parameter, that is along the positive x-axis. And what about m2? M2 was moving with a velocity -5, that means it must be taken along the negative x-axis. And we do know that after collision they will simply exchange their speed and direction. So m1 will move in which direction? M1 will move opposite to the initial direction. And what will be the speed? Speed will be the new speed after collision will be the speed for the second particle, that is -5 meter per second. And what about the second particle? Second particle was initially moving in the left hand direction, but due to the elastic nature it will reverse its direction along the positive, and its value will be equal to 3 meter per second. And our answer will be option number D. Very simple. So such type of question should not be calculated. This type of question should be done with the help of our concept. That's all for today. We have completed collision portion. Later in the evening we will start new rotational motion.